Alright, enough about 2D shapes. Let's talk about 3D shapes or space figures. The first thing we need to know is about a lateral face. No, not that face. No, keep trying. Okay, so it's 2D parts of a 3D figure, except for the bases. So lateral faces could just be maybe a whole bunch of rectangles. Or they could be a bunch of triangles. Now an edge is where the faces or the bases come together. So an edge is just a line segment that joins faces and or bases. Alright, and the two major figures we have for 3D figures are prisms and pyramids. Alright, now let's attempt to draw these with me. I'm going to draw the first prism that you see here, and it's named by its base. So this is actually 1, 2, 3, 4, 5 sides. So that's a pentagon. So draw your pentagon with me. And I'll actually draw this underneath so you can see I'm not cheating. And then you can draw another pentagon in the back. So just diagonally to the right of that. And I'm drawing it, trying to eyeball it, but make it about the same size. And now I'm just going to connect each of the vertices, that bottom right point. And then this one's where I can't see, so I can use a dotted line there if I want. The top one, the far right one, and then I can't see this one, it's behind the figure, so I'll just use a dotted line there. And now you have a Pentagonal Prism is the name of that. So underneath of it, let's give it a name. And now let's talk about our Pentagonal Prism. And actually about any prism, these are some qualities that are always true. Alright, so check it out. Prisms have two bases, and they're always going to be congruent. So we have this pentagon here, and they're also, their planes are parallel to each other. And then their lateral faces are rectangles. So look at this lateral face. There's a rectangle, that bottom part there is a rectangle, so it has 5 rectangles there. And it's named by the base. So we had 5 sides for our base. So we call it a pentagonal prism, or a 5-sided prism. Alright. Not so bad. So all prisms are like that. Those are qualities every one of them has. Now it's a little different for pyramids. As you can see from our diagram here, pyramids have how many bases? Yeah, just one base. And what do you notice about their lateral faces? What shape is this? That green area, that pink area, the yellow area. Those are all triangles. And that's true for all of pyramids. And they're still going to be named by their base. Alright, so one base, lateral faces are triangles. It's named by the base, just like a prism. So this one has 1, 2, 3, 4, 5, 6 sides. So we would call that a hexagonal pyramid. And it comes to a point. So the very top of it, I guess depending on your point of view, all those lateral faces come up to a point. Alright, let's try drawing one right now. And maybe we'll start a little easier. We'll just draw a square pyramid. So just draw a square. And then up from that square, I'm going to put a point. And then on that point, I'm going to connect it to each of the vertices. So connect it there, there, and there. So I'm connecting it in 4 locations. Alright, and you can see we have 4 triangles that made. So that would be 4 lateral faces. And the base is a square, so that's why this one is called a square pyramid. And let's label that. Alright, let's take a second for each of our figures, and we're going to label how many bases, lateral faces, and edges they have. Alright, well let's go ahead and figure out for our pentagonal prism. The number of bases, it's a prism, so we know it has 2 bases, so that part was easy. But the lateral faces, honestly you can just look at how many sides the base has, and that will tell you how many lateral faces you have, because you have a rectangle coming out from each side of your base. So from this side we have this rectangle, there's 1. There's 2, there's 3, there's 4 behind us that we can't see, and there's 5 on the bottom. So really you just have 1 rectangle coming out from each side. So the trick is just count the number of sides of your base. So that would be 5. And then your number of edges, well let's look. We have 5 edges on our base. 5 edges on this base, so there's a total of 10. And then we just count the number of connections that are made. So there's an edge, there's an edge, there's an edge, so there's 5 going out from there as well. So again, we had 5 on our base, 5 on this base, and then 1, 2, 3, 4, 5. So 5 were connected. So 5 plus 5 plus 5 gives us 15 edges. Alright, check out our pyramid over here. And the number of bases, well it's a pyramid, so we know there's only 1 base. Lateral faces, again, just look at how many sides your base has, and that'll tell you how many faces you have. So you have 1 triangle, 2 triangles, 3 triangles, and the back triangle there. So again, you have 1 triangle extending from each side of your base. So your base has 4 sides. So you have 4 lateral faces. All right, your number of edges. Well, we know there's 4 edges on the bottom because we have 1, 2, 3, 4. It's a square. And then look at how many connections you have to that top vertex. There's 1, 2, 3, 4. So we have 4 plus 4, which would give us 8 edges. All right, and just for practice, how many vertices do you have? Vertices just means points. I have 1 point there, 2, 3, 4, 5. Why don't we add that to one of them, because you should be familiar with vertices. That's just the plural for vertex. And again, we have, so it's just 5 points. And I'm saying that word points just to make sure that you know what a vertex means. So again, 1, 2, 3, 4, 5. Let's count over here on this one. We have 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So we have 10 vertices on this one. So 10 points. Did you find a shortcut with that? Well, yeah, you have 2 bases, right, on a prism. So however many sides are on your bases tells you how many points you have. So it's just 5 times 2, which gives you 10. What about for the pyramid? Did you figure out the shortcut? You only have one base, so that means you have whatever number of points your base has, or number of sides that your base has, is how many points you have. So a square has 4, and then you just add the point that it comes to at the top. So it's always plus 1. So a hexagonal pyramid has 6 points, and it comes to a point at the top, so 6 plus 1 would be 7. Alright, let's just talk about a couple more shapes. Think about a typical soda can. It's going to be in the shape of a cylinder. So a cylinder is just going to be 2 circles that are connected. So just draw that picture of a cylinder. So a circle, circle, and then just connect the edge of your circle there. And you have a cylinder. And notice your circles are going to be congruent. Alright, now we'll draw a cone. So a cone is just going to be one circle that comes up to a point. Alright? And then a sphere, it's just like a basketball. It's hard to really show that a sphere is a three-dimensional object. So just draw a circle and then put a dot in the center. And you want to kind of do a dotted line around it. And then it's basically like you're drawing a circle within a circle. I know this looks more like an oval, but that's just because of our position as we look at it. So you just have a center dot and you're drawing a circle around it basically. And that gives us the 3D look to it. Alright, now that we've talked about most of the 3D shapes, we want to talk about what they look like if you were to, let's say, use wrapping paper to wrap a present in that shape. So what does the net look like for those? So the net, I'm going to say nets here, the nets are just going to be that shape as a two-dimensional figure. So go ahead and draw just a pentagon, and then draw a rectangle connecting that to another pentagon. And I'll move the figure so you can see what I'm doing. And I have another shape right here, or another side. So I need to have another rectangle coming from there. So I'll just draw that right here. Then I have another side up here, so I need another rectangle showing that. So I'll connect that right here. And then the same thing on this side. I have a side that's going to be connected to the other base, so I need a rectangle there. And then I have one more up here that needs a rectangle connecting to it. This is one way to draw a net. And now you can see if I fold it up, if I folded this side up, it would connect here. If I folded this side up, it would connect here. That side would connect over here, and that side would connect there. So you just want to make sure that you have a rectangle for each side. So I have 5 sides, so I have 1, 2, 3, 4, 5 sides here. Alright, not too bad. Now here I have a, look at the base, it's a pentagon, so each of the pentagons needs a triangle coming from it. And if I folded each of these orange triangles up, it would come to a point, making it a pyramid. So just take a second and draw that with me. Just draw another pentagon. And then from each side of, woohoo, that's a interesting looking pentagon, isn't it? From each side of your pentagon, just draw a triangle. And make them all looking congruent, about the same size. Alright, I went ahead and named those two figures. So pentagonal prism because it has two bases, pentagonal pyramid because it has one base. And our last shape is going to be a cylinder. And think about what a cylinder is. If you take a piece of paper and roll it up, you can basically create a cylinder. So it's just a rectangle that has two circles on it, two congruent circles. But the cool thing about a cylinder is you have that curved surface, but like I said, it's just a rectangle. So just take a piece of paper and roll it up like so go ahead, act like a pirate and roll up a sheet of paper like you're looking far away, and you're just creating a cylinder when you do that. We did some math today.